Hello everyone. Today I'd like to deliver the lecture on the theme Planetary Boundaries and Climate Change, Navigating Global Limits for a Sustainable Future. Currently we have the environmental issues that have reached an alarming level, with continuously advancing deforestation, fast lost biodiversity, soil erosion, desertification, air pollution, and the rising tide of plastics in the oceans. The last 10 years have brought record-breaking extremes fires in Australia, Siberia, California, and the Amazon. More frequent and more intensive floods in China, Bangladesh, and India. More frequent and more prolonged heat waves and droughts across the northern hemisphere. Water crisis caused with these conditions. Now we need to address these pressing issues, and the concept of the planetary boundaries is very helpful, because it allows us to understand how human growth and human activities has impacted the environment. The concept of planetary boundary was introduced in 2009 by a group of researchers led by Will Steffen from Australian National University and Johan Rockström from Stockholm Resilience Center at Stockholm University. What are the planetary boundaries? Imagine Earth as a spaceship speeding through the vastness of the universe, carrying all the resources needed for life. Planetary boundaries are like the control bar or dashboard in our spaceship, helping us navigate and ensure the health and stability of our onboard systems. And thus we can define the planetary boundaries as the safe operating limits of humanity, or dashboard of human altered Earth system dynamics, or precautionary measures for continued functioning. And the concept of planetary boundaries identifies 9 critical Earth system processes that help maintain the resilience of stability of our planet. These boundaries include climate change, biodiversity loss, ocean acidification, land use change, fresh water change, novel entities, atmospheric aerosol loading and biogeochemical flows. If humanity stays within these planetary boundaries in the green zone, the humanity stays in the safe area. If we are moving towards the green, the yellow and orange zone, we are moving to the area of increasing risk. And if we are in the purple zone, we are in the area of high risk. And transgressing these boundaries can lead to severe consequences. For example, the founder of Planetary Boundary concept, Johan Rockström, claims transgressing one or more planetary boundaries may be deleterious or even catastrophic due to the risk of crossing thresholds and triggering non-linear abrupt environmental change within Earth's systems. Now we will consider some of the planetary boundaries and the consequences transgressing of their transgressing. And we will begin with climate change planetary boundary, because climate change planetary boundary, along with biosphere integrity, is a core boundary in this framework. Why? Because the geosphere biosphere interactions are the internal driver of the Earth system state. And in this framework, the climate change is used like a proxy for the geosphere. And climate can be changed by a variety of key factors, such as solar radiation, incoming solar radiation, change in the Earth's albedo, and greenhouse gas concentrations. And maybe we need to stop a little bit such terms as albedo and greenhouse gases, because these terms are widely used, but their definition is not always clear. What is albedo? Albedo is a measure of how much sunlight a surface reflects. A surface with high albedo reflects most of the sunlight staying cooler, while a surface with low albedo absorbs more sunlight, warming up. For example, snow and ice have a high albedo, so they reflect up to 90% of sunlight back into the space, keeping the Earth cooler. Darker surfaces, such as oceans, have a low albedo, and they absorb more sunlight, up to 94%, which warms the Earth. This is why melting Arctic sea ice can lead to more warming. Less ice means less reflections and more heat absorbed by the surface. What are greenhouse gases? Greenhouse gases are the gases in the atmosphere that raise the Earth's temperature. They are transparent to the shortwave sunlight radiation and absorb the infrared radiation that the Earth emits, resulting in the greenhouse effect. And to understand combined effect of these key factors, such as solar radiation, greenhouse gases, and change in albedo, we need to consider such a concept as radiative forcing. Radiative forcing concept tells us how the amount of energy in the form of radiation that enters the Earth's atmosphere differs from the amount that leaves it. And positive radiative forcing implies more energy coming in than going out, which increases Earth's temperatures, while negative radiative forcing implies more energy going out than coming in, cooling the Earth. Over time, this temperature change helps balance the Earth's energy. And this image, we see the key components of radiative forcing. The most significant component is carbon dioxide, a relatively weak greenhouse gas, but heavily emitted by human activities. Methane, nitrous dioxide, and other gases also contribute to warming atmosphere. And in the top right corner of the slide, we can see all sources of greenhouse gas emissions. These sources include energy sector, agriculture and land use change, and also waste and industry. Aerosols, on the other hand, scatter sunlight, increasing albedo and cooling Earth. Ozone is a gas found in different layers of the atmosphere, and it affects Earth's climate in opposite ways depending on its location. If in the troposphere, which is the lower part of the atmosphere where we live, ozone acts like a greenhouse gas. Because tropospheric ozone, mostly created from pollution, is warming the air around us. In the stratosphere, the layer above the troposphere, ozone plays a protective role. It absorbs much of the sun's harmful ultraviolet radiation, stopping it from reaching the Earth's surface. Let's consider this very interesting image. This image shows temperature changes over the last 100,000 years. They're revealing that the highest and most stable temperatures have occurred during the last 11,500 years, a period known as the Holocene. Such stable climate helps the humanity to grow and to develop. Note that during the Holocene, the temperature did not vary by more than 2 degrees from its average value. However, in the past 150 to 200 years, human activities have increasingly damaged and disrupted the environment. Because of that, today temperature have risen sharply, and there is a high risk that they will exceed the 2 degrees thresholds. Why is this likely to happen? It can happen because in addition of the effects of radiative forcing, there are also processes that can either amplify or reduce the effects of climate forcings. These processes are known as feedbacks, which can act as tipping cascades, either warming or cooling our planet. Feedback that amplifies initial warming is called a positive feedback, while feedback that reduced initial warming is called a negative feedback. And in this slide, we can see the map of negative and positive climate change feedback loop in the case of rising the rising temperature of the Earth. And in this slide, we can see the Arctic sea ice loss feedback loop, and we considered this feedback loop in details, and now we know very well that the loss of Arctic summer ice amplifies regional warming. And the other climate change feedback loop is permafrost thaw. This feedback loop leads to the release of greenhouse gases such as carbon dioxide and methane, which further intensify warming. Similarly, the dieback of boreal forests and Amazon rainforests contribute significant amounts of carbon dioxide to the atmosphere. And this effect is often exacerbated by wildfires. Some climate changes can be reversed within 50-100 years, like changes in Arctic sea ice due to warming or cooling. However, Antarctic sea ice may be harder to restore because of heat stored in the Southern Ocean. Most changes, like the release of carbon from melting permafrost, are effectively irreversible within time frames important to the modern society. The impact of climate change depends on how quickly it happens. If the change is slow, ecosystems can adjust to a change in temperature and moisture. And they might even help absorb carbon from the air. However, if the change is too fast, ecosystem may reach a tipping point, causing sudden changes, like wildfires, insect outbreaks, or droughts that destroy ecosystems. For example, large wildfires can release a lot of carbon into the air, which could affect the Earth's climate. All these rapid changes can lead to very serious consequences. The diagram on the slide shows the Earth's path over the past 100,000 years. In the bottom left corner of the image, and its possible future path in the top right corner. The vertical line represents the temperature level during the pre-industrial period.